is 11.5, homework number 1, solving rational equations. A rational equation is an equation that contains one or more rational expressions. And so what did you expect? We were going to be doing more with rational expressions since we've been doing that for the last several videos. But let's do a little bit of review from chapter 2, way back last semester. So when we did this, I taught you how to clear the fractions by multiplying by the LCM. So LCD and LCM are the same thing. But LCD is when we're trying to get common denominators. LCM is when we're trying to clear the fractions and we're multiplying by the LCD. So hence multiplying, least common multiple. So quick review on finding least common denominator or least common multiple. We look at the denominators. Notice that 10 does not have a denominator. So that denominator is 1. It doesn't have a denominator written, so it's a 1. So I'm not looking at that 1 to determine my LCM. All right, there's nothing they have in common. So two factors have in common. The two denominators have in common. So 2 times 2 times 3, that will be 12. So instead of making each one of these into a 12, what I'm going to do is multiply each term by 12. So I'm just going to put 12 in each numerator. And then I'm going to reduce. So 4, I'm trying to make these denominators into 1. So 4 goes into 4 one time, 4 goes into 12 3 times. So I'm going to multiply this 3 times this 3x. So that will be 9x. Go to the next one. 3 will go into 3 once. 3 goes into 12 4 times. So multiplying this 4 times x. That is 4x. So notice I no longer have a denominator written because it's now a 1. Equals. Now over here, my denominator is already 1. So I'm just going to multiply 10 times 12. So that's 120. And now I have a simple equation that I can now solve. So combine like terms. 9x minus 4x is 5x. And divide by 5. So x equals 24. So that's a quick review from chapter 2 whenever I taught you how to clear fractions in an equation in order to solve. Alright, so let's get started. So using the material from chapter 2 and the material from section 11.4, homework number 2, we're going to find the LCD, which is actually the LCM. And I told you that if all the fractions have a denominator of 1, but one of the fractions is something else other than 1, then that is your LCM. So in this case, my LCM is y. So that's the only term in a denominator besides the ones in the other. So I'm going to multiply each term times y. Okay. So in this particular, the first fraction, the denominator is already 1. So I'm just going to multiply y times y. So that's y squared. And the next fraction, the y's cancel out. Y divided by y is 1. So I'm basically just multiplying 1 times 9. And then my last fraction, which is actually a fraction, I know it's negative 10, but it's actually a fraction. It's actually something I have to multiply by the y. I have to multiply every single term by y, not just the one that has a y in the denominator. So we already have a 1 in the denominator, so I'm just going to multiply negative 10 times y, which is negative 10y. Now, we learned back in I think it was chapter 9, section 4, we learned that whenever there is a exponent that is 2 or more, then we have to solve this by using factoring. So the rules for factoring are first to get it in standard form. So I need to get this side to be a 0. So I have y squared plus 10y plus 9 equals 0. That will factor to y plus 9, y plus 1. Now we take each factor, each binomial, set it equal to 0, and solve. So y equals negative 9 and y equals negative 1. Now notice this little Oh, never mind. It doesn't have that. Okay, so we're going to write -9 and -1 in our answer. What we want to do is always kind of just visually check our answer and make sure that the answers we get for y, -9 and -1, do not make this denominator into a 0. So -9 does not make that into a 0, and -1 does not make that into a 0. So just make sure you do that visually before you put your answer down. Okay. Number 2, I have two fractions that have the same variable. I have one that has a 1, and since the other two have the same variable, then the LCM is that variable. So I'm going to put a P in each term, in the numerator of each term. So this one's already a 1, so I'm going to multiply 2 times P. Here the P's cancel out, so that's +4. And then the last one the P's cancel out, so that is +8. Now I have a real simple equation to solve. I don't have to factor on this one because my exponent is not a 2 or more. So I just subtract 4 and divide by 2. This 2 does not make that denominator or that denominator into a 0, so the solution is 2. All right, so far so good? I hope so. All right, here I have 3 denominators, 4x, 7, and 4x. 2 of them are the same, so I'm going to find the LCD. That's 2 times 2 times x. Some of you can probably already see what the LCD is going to be, or LCM is going to be. They have nothing in common, so I'm multiplying 2 times 2 times x times 7, which is 28x. So this is my LCM. So I'm going to put 28x in each, 28x in each numerator. I'm going to squeeze it in somewhere. All right, so I'm not going to multiply 28x times 17 because I'm trying to reduce this. I want this 4x to become a 1. So 4x goes into 4x once. 28 divided by 4x is 7. And now I'm going to multiply 7 times 17, which is 119. Plus, go to the next one. I want to make this 7 into a 1, so divide by 7. 28x divided by 7 is 4x. Multiply 4x times 2, 8x, equals, over here, I want to make this 4x into a 1, so divide by 4x. 28x divided by 4x is 7. So I'm multiplying 7 times 9, which is 63. Now again, I don't have an exponent 2 or more, so I'm just going to solve it. Subtract 119 from both sides. 8x equals -56. Yeah, -56. And divide by 8. So x is equal to -7. So -7 does not make either one of these denominators into a 0. So -7 is my solution. All right. Number 4. I have 1. So I'm going to make that 1 over 1. Plus 3 over x equals 18 over x squared. So I have an x and I have an x squared. X is just x. X squared is x times x. They do have one x in common, but they also have an x not in common. So I'm going to multiply what they have in common times what they don't have in common to get my LCM of x squared. So I'm multiplying each numerator by x squared. And then I'm going to reduce. Now the first one already has a 1 for a denominator, so I'm just multiplying 1 times x squared. And the next one, x divides into x once. X squared divided by x is x. So multiplying 3 times x, that's positive 3x. Equals, the last one, x squared divided by x squared is just 1. So 1 times 18 is 18. Now remember, when you have an exponent that's 2 or more, you have to use the factoring rule. So that means I need to get it in standard form. So I'm going to subtract 18 from both sides. X squared plus 3x minus 18 equals 0. Factor x plus 6, x minus 3. Oops, that's a 0. And then we take each factor. Let me try that again. X plus 6 equals 0. X minus 3 equals 0. So x equals negative 6 and x equals positive 3. Now do either one of these make my denominators into 0? 3 squared is not 0. 3 is not 0. Negative 6 is not 0. Negative 6 squared is not 0. So, but the solutions are negative 6 and positive 3. Okay. Here we have 3 different denominators, 2p and 2p. So let's guess what the LCM is. We have 2, we have p, and we have 2p. So 2 is 2, p is p, 2p is 2 times p. So two of the denominators have a 2 in common. The other 2 denominators have a p in common. So the LCM is 2p. So we're going to put 2p in each numerator and reduce. Don't multiply when you're doing this. Go ahead and reduce first. So 2 divided into 2 once. 2 goes into 2p. P. So p times 7 is 7p. Minus p goes into p once. 2p divided by p is 2. So 2 times 8 is 16. Equals 2p goes into 2p once. 2p goes into 2p once. So 1 times 5 minus 2 is just 5p. Sorry, minus 2. All right, so we have an equation with variables on both sides. So I'm going to subtract the smaller variable term first. That's what I taught you back in chapter 2. Then I'm going to add 16. And then divide by 2. So p equals 7. Does that make either one of these denominators 0? No, it does not. So the solution is 7. Okay, so that's some solving equations by multiplying by the LCM. Now we're going to look at solving 2 equations by using cross products, cross multiplication. I can only do this when I have a fraction on one side and another fraction on the other. A rational expression on both sides, not more than one. One rational expression on each side. And so what I'm going to do is I'm going to cross multiply. So I'm multiplying x plus 6 times x plus 1 on one side. And on the other side, I'm multiplying 8 times x plus 1. So here we have to FOIL. Here we have to distribute. All right, so this is x squared plus 7x plus 6 equals 8x plus 8. I do have an x squared term, so I want to move these 2 terms to this side where my x squared term is. So I'm going to subtract 8x, and I'm going to subtract 8. Now notice I lined up my like terms. So I have x squared minus x minus 2 equals 0. Factor. Take each factor, set it equal to 0, and solve. So x equals 2, and x equals negative 1. All right, so does 2 make either one of these denominators 0? No, it does not. Does negative 1 make either one of these zeros? Yes, it does. So negative 1 is not a solution. Only positive 2 is. So be careful. All right, this one, again, we're using cross products. I have a rational expression, one rational expression on the left and one rational expression on the right. So I'm using cross products. I'm multiplying x plus 6 times x minus 4 on one side. And on the other side, I'm multiplying x plus 3 times x minus 2. So both sides, I am using FOIL. So this is x squared plus 2x minus 24. And over here, x squared plus x minus 6. Now, I have x squared on both sides. So, I'm not going to have to factor on this problem because the x squared terms zero out. So all I'm going to do is move my smaller variable term, which is now x, and then add 24. So x equals 18. Does 18 make either one of these denominators into a 0? No, it does not. So my answer is 18. All right, one more, cross products. Now this is a word problem, but they gave you the equation. So you really don't have to worry about how to set this up. You just need to realize you're going to have to cross multiply because I have a rational expression on this side and a rational expression on the other side. So cross multiplying, I have 540 times 250 minus s. If you don't like that s, I say change it to another variable. So I'm going to change it to an x. Just because it might look like a 5 as I'm doing this. I'm going to change both of these to an x. It doesn't matter what the variable is in this particular problem because I'm solving for this variable. It doesn't have to be part of my equation. Now this is the only time you can do this. Okay, so whenever I do the distributive property on both sides, I'm going to get some pretty big numbers, but that doesn't mean you're wrong. These are big numbers. All right, so 540 times 250 is 135,000 minus 540x. Over here, 460 times 250 plus x is 115,000 plus 460x. Now, I like to move my smaller variable term first. To me, it just makes it, that's an x. It makes it easier. So I have 135,000 equals 115,000 plus 1,000x. Now I'm going to subtract 115,000 from both sides, trying to get the 1,000x by itself on one side. So this is 20,000, not 2,000. And then divide by 1,000, and I get 20. Now, does 20 make either one of my denominators into a 0? No, it does not. So the speed of the wind is 20 miles per hour. And that, my friends, is 11.5 homework number 1.